Okay, looking at solutions of systems of linear equations, we're going to be looking at both homogeneous and non-homogeneous equation systems. And now for what we have in Theorem 4.18, we have solutions of a non-homogeneous linear system. And we have that if x of p is a particular solution of the non-homogeneous system, a times x is equal to b, then every solution of this system can be written in the form x is equal to x of p plus x of h, where x of h is a solution of the corresponding homogeneous system, a times x is equal to 0. And just kind of looking at initiating what we have as we make a segue from homogeneous to non-homogeneous equations. And let's say that if we're looking at finding a basis and dimension for the following homogeneous systems of linear equations. And we have from, say, the textbook, if you have in number 45, okay, we have a 3-equation system where we have looking at solving for x of 1, x of 2, x of 3, and x of 4. And setting things up, if we establish A as the coefficient matrix, okay, so A consists of 3, 3, 15, and 11. For the top row, middle row, we have 1, negative 3, 1, and 1. And we also have 2, 3, 11, and 8. And for finding out what the dimension is going to be, first of all, we had to know how many columns A has. And in this case, it has 4 columns. And looking at what we have for this homogeneous equation system, okay, so you have, again, a times x is equal to 0. And for x, okay, again, we're looking at solving for x of 1, x of 2, x of 3, and x of 4. And again, we have this matrix times x, this vector matrix, is equal to 0. And if we express as an augmented matrix, okay, so we have, in addition to what we have for A, we have, again, the addition of zeros forming this 5th column. And expressing what we have in reduced row echelon form, okay, we have 1, 0, 4, 3, 0 in the top row. Middle row, we have 0, 1, 1, 2/3, and 0. And we have the last row is 0. And so we have, there are 2 non-zero rows. So for the rank of A, okay, that is going to be at 2. So the number of non-zero rows and the rank are the same. And from what we have in the case of the top row, okay, so we have x of 1 plus 4x of 3 plus 3x of 4 is equal to 0. And rewriting in terms of x of 1, so we're going to have x of 1 equal to negative 4 times x of 3 minus 3 times x of 4. And from the second row, we have x of 2 plus x of 3 plus 2/3 of x of 4 is equal to 0. And isolating x of 2, so we have negative x of 3 minus 2/3 of x of 4. And now x of 3 and x of 4 are going to be free variables. And just putting the subscripted sequencing as well as the order of the variables arranged alphabetically, we can say that we have x of 3 is equal to s and x of 4 is equal to t. And so rewriting what we have in terms of s and t, so we have for x of 1, okay, we have this difference to translate out to negative 4s minus 3t. And for x of 2, we're going to have negative s minus 2/3 of t. And so looking at what we have for x, okay, so we have just separating, okay, so we have corresponding to x of 1 as well as x of 2, x of 3, x of 4. So you're going to have s times, okay, the 4×1 vector consisting of negative 4, negative 1, 1, 0. And we had the 0 on the bottom due to the fact that x of 4 is equal to t, so there's no presence of s. And then we have followed by t, okay, and we have times, and we have in the vector, we have negative 3, negative 2/3, 0, and 1. And again, x of 3 is an s term only, and the 1 at the bottom signifies that x of 4 is equal to 1t. And so we have, as a basis for the solution space, okay, we have s equal to, and we have from the first vector, okay, we have the numbers, we have negative 4, negative 1, 1, and 0. And again, we have, for the coefficients inside the vector alongside t, we have -3, -2/3, 0, and 1. All right, Now, as another situation here, and before I get to the next system of equations, okay, now the dimension or the nullity of A is going to be the number of columns, again, which we had with 4, minus the rank of A. Okay, so the rank of A was 2, so the nullity or the dimension of A comes out to 2. Now let's say if we have with this 4 equation homogeneous system, okay, and again we're looking at solving for x, where we have x containing what we have with x sub 1, x sub 2, x sub 3, and x sub 4, and establishing our coefficient matrix. Okay, so we have a 4 by 4 arrangement, and A has 4 columns. And now for A times x is equal to 0, and again x consisting of, okay, what we have with the solution variables x sub 1, x sub 2, x sub 3, and x sub 4, we can establish an augmented matrix. Okay, so we have for this arrangement, okay, so we got the augmented matrix. Again, we have with the fifth column of zeros added, and that is to set it up where we had the augmented matrix counterpart to matrix A times matrix X is equal to 0. And for the reduced row echelon form, okay, so you have 1, 0, 0, negative 4 thirds 0 at the top. Middle row, or I should say the second row, we have 0, 1, 0, 3 halves 0. Third row, we have 0, 0, 1, 1, 0. And the last row, we have consisting of zeros exclusively. And we have 3 non-zero rows, and the rank of A is going to be at 3. And just setting up what we have for the solution variables going from x sub 1 to x sub 4. Okay, so we have, first of all, we have x sub 1 minus 4 thirds of x sub 4 is equal to 0. And so we have rearranging in terms of x sub 1. We have x sub 1 is equal to 4 thirds of x sub 4. And we have for the second row, again, when we have 1 is in reference to x sub 2, and the 3 halves will be in reference to 3 halves of x sub 4 is equal to 0. And so we have x sub 2 is equal to negative 3 halves of x sub 4. And for the third row, we have x sub 3 plus x sub 4 is equal to 0. And we have the x sub 3 is equal to negative x sub 4. And out of these, okay, so there is no row signifying that we have any possibility for x sub 4 to be expressed in terms of any relation. So we had the x sub 4 is free, and we can assign the variable t. And since x sub 3 is equal to the negative of x sub 4, we have x sub 3 is equal to negative t. And we have x sub 2 is equal to negative 3 halves of t, and x sub 1 is equal to 4 thirds of t. And so for what we have for the solution matrix in X, okay, so again, since all of x sub 1 to x sub 4, okay, will consist of the variable t. So we have t times the vector matrix consisting of 4 thirds, negative 3 halves, negative 1, and 1. And so a basis for the solution space, we could say, if we keep the fractions as they are, we could say we have 4 thirds, negative 3 halves, negative 1, and 1. And if I were to express everything in terms of integers, I could just take the least common denominator, which is 6, just multiply everything out. And you can also have as a basis for the solution space, you can say we have 8, negative 9, negative 6, and positive 6. All right. And again, for the dimension or the nullity of A, okay, again, we had 4 columns, and we had 3 non-zero rows, excuse me. So the rank of A, again, was at 3, and the difference we had to be the dimension of the system, which in this case is equal to 1. All right, now in the case of crossing over to what we have with non-homogeneous system equations, or equation systems. Okay, so the system AX is equal to B is consistent if and only if B is in the column space of A. And okay, now just looking at what we have with non-homogeneous systems, and it says to determine whether the non-homogeneous system AX equals B is consistent, And if it is, write the solution in the form of where we have x is equal to x sub p plus x sub h, where x sub p is a particular solution of a times x is equal to b, and x sub h is a solution of a times x is equal to 0. And let's say if we have a system of equations where we have 3x minus 6y plus 21z is equal to negative 3, and we have negative 2x plus 4y minus 14z is equal to 2, and 3x plus 2y plus 3z is equal to 6. And if we set up the coefficient matrix A, okay, so you have first column in reference to the x term coefficients, second column for what we have in y, and third and last column for what we have in z. And again, A has 3 columns. Now for the setup, we have A times x is equal to b. And again, so x we have consisting of x, y, and z. And for what we would have in b, that would be negative 3, 2, and 6. And if I write as an augmented matrix, okay, so I have A with its coefficients already established, and again, B, we have negative 3, 2, and 6, and so that is going to be included as a fourth column in the augmented matrix. And writing in reduced row echelon form, we have 1, 0, 5, 5 halves, 0, 1, negative 1, 7 fourths, and we have the last row consisting of zeros. Okay, and since we have zeros running across, okay, there's no contradiction. Like if I had like 0, 0, 0, 1, there would be a contradiction and the system would be inconsistent. However, since we have zeros running across, there's no conflict, so the system is consistent. And we have with the top row, we have x plus 5z is equal to 5 halves. And if I write in terms of x, we have equal to 5 halves minus 5z. Then for the second row, we have y minus z is equal to 7 fourths. And rearranging in terms of y equals, we have 7 fourths plus z. And z is a free variable. And we can write z as being equal to t. And writing x in terms of the variable t, so we have 5 halves minus 5 times t. And for y, we have 7 fourths plus z, which translates out to 7 fourths plus t. And so we have for x, we're going to have for the solution, and splitting up, we're going to have for the particular solution, this will be the items with the constants, where we have 5 halves, 7 fourths, and 0. And the x sub h on the homogeneous side, okay, we have with t times all of negative 5, 1, and 1. So that would be your solution. And for the remaining system, also non-homogeneous, okay, so we have a 4-equation system looking at solving for x, y, z, and w. And we have non-homogeneous on the basis that we don't have the equation set equal to 0 throughout. And setting up what we have for the coefficient matrix A, and arranging this where we have A times x is equal to B. So x we have consisting of x, y, z, w, and explicitly laying out or identifying what B is. Okay, so that's a 4x1 matrix. So you have 2, 3, 1, and 1. And expressing what we have consolidating as an augmented matrix. So again, the first 4 columns have the elements from matrix A, and the 5th column comes from what we have in B. And taking this 4x5 matrix and expressing in reduced row echelon form. So the first row we have is 1, 0, 0, negative 4 thirds, 0. Second row we have 0, 1, 0, 3 halves, and negative 1 half. Third row we have 0, 0, 1, 1, 0. And the last row we have zeros throughout. So on the basis that we have zeros all throughout, we have a consistent system. And if I had zeros across, but the 5th column, last row had like a non-zero value, then we would have had an inconsistent system, and there would have been no solution for the system. But since the system is consistent, we can proceed. And so from the first 3 rows, okay, we have that x minus 4 thirds of w is equal to 0, and so we can say that x is equal to 4 thirds of w. From the second row, we have y plus 3 halves of w equals negative 1 half. So we have that y is equal to negative 1 half minus 3 halves of w, and we have z plus w is equal to 0. So z and w will have an additive inverse relation. And w, since we cannot isolate this after having isolated x, y, and z, okay, w is regarded as a free variable, and we can set this equal to t. And since z is the opposite sign of w, we have that z is equal to negative t. And replacing w with t, it turns out that for what we have in the case of not x to 2 but y, we have y is equal to negative 1/2 minus 3/2 of t. And for x, not x of 1 but x, okay, we're going to come out to 4/3 of t. Okay, and so let me go ahead and make that correction. Okay, so you have y and x. And so for what we have in the follow through, okay, so you have x, again, we have x, y, z, w, and filling in, so again, x is equal to 4/3 of t, y we have at negative 1/2 minus 3/2 of t, z we have at negative t, w we have at t, and then separating, okay, so just for the constants, okay, nothing from x, and we have negative 1/2 from y, and we have from z, nothing, w also nothing, since x, z, and w consists of only the variable terms. So you have 0, negative 1/2, 0, 0, and then we have plus t, and then we have 4/3 minus 3/2 from the minus 3/2 of t, spinning off from y, and we have negative 1 and 1. And the 0, negative 1/2, 0, and 0, that is the x of p portion. And for what we have in the case of the coefficients inside the matrix alongside t, okay, that's going to be the x of h portion.